So welcome to today's lesson on the turning effects of forces. Let's talk about torque. So there are 4 learning objectives for today's lesson. The 2 core learning objectives, which are recall and use the relationship of moment equals force times perpendicular distance from a pivot, and then also recall that the weight of a body acts through the centre of gravity. And the 2 extended learning objectives are about recalling and using the principle of moments for a simple system, usually with parallel forces acting on the x-axis or single plane, and then understand that the upward force of a light on a light beam is supported at both ends, varies in position of the object that's between those 2 beams. We'll look at a lorry as an example of that. So, moment of a force. So this is also known as the turning effect of a force, also known as the torque of a force. Okay, and the moment is going to be the force times the perpendicular distance from the pivot. So we can see, for example, on the right with that wrench, you have the pivot, which is going to be the actual screw or the nut you're trying to unscrew, and you've also got the perpendicular distance from that particular nut to your hand where the force is being applied. And the moment equals force times distance, and the units are Newton meters. And as you can see with a wrench, you can either pull it towards you or pull it away from you. So moments can either be clockwise or anti-clockwise. So another important principle is the center of gravity or center of mass. And the center of gravity, as you can see in the red, the definition of a body is the point at which all the weight of the body acts. Okay, so your center of gravity usually is going to be right kind of in the center of you, okay, around where your stomach is. And the center of gravity of a symmetrical body is along the axis of symmetry. That's why you're pretty symmetrical. So that's why your center of gravity is usually in the middle of you. And you can see there from the circle and the triangle that the center of gravity is usually smack bang in the center of regular shapes. However, if a body is suspended, like these 2 pot plants, then the center of gravity is directly below the point of suspension. Okay, so here's 2 pot plants, A and B. You can see in the first one that the weight is directly below the center of gravity, and as you move the point of suspension, so the center of gravity also moves for that particular pot plant. So how do you find the center of gravity for an object, or in this case a card? We'll do this experiment in class. So pierce the card in at least 2 places, preferably about 3 to get a number of values. Suspend the card from one of the holes, and then use something called a plumb line, which is essentially just a piece of string with a mass at the bottom on one of these holes. Okay, you suspend it from one of these holes, and then you hang and plumb the line to the point of suspension, and then you draw that line as a reference point for a vertical line on the card, and then you repeat that for the other 2 holes that you've made. And when you join those lines together, you will find the center of gravity for that particular object. So a lot of exam questions around stability. Okay, these 3 images illustrate that. So a body is stable as long as the center of gravity remains vertically above its base. Okay, so think of basically a milk carton, for example. In the first example, the center of gravity is just above the base, so it's fine, it's stable on the kitchen table. And then as you move it, you can see that it's no longer above the base, and it's going to topple over onto the kitchen table and make a mess, which you have to clean up. Okay, the body will topple. It's the same with you. If you stand directly up, you're above the base, your feet, and then if I push you slowly, then you're no longer above your feet, your center of gravity, so you're going to topple over onto the ground. So this is more the extended content. It's the principle of moments. So when an object is not turning, i.e. the forces are balanced, then the total clockwise moment equals the total anti-clockwise moment. So that's an important point. So it's in red, so remember that concept. And so if we look at the ruler in the diagram in the image, you'll see that the clockwise moment will equal the anti-clockwise moment. So the weight times the distance from the pivot on one side, the clockwise moment, will equal the weight times the distance on the other side of the pivot, the anti-clockwise moment, when it is balanced. That's an important concept. And the reason why it's important is when we look at an object and look at the forces acting on that object on a beam or a bridge. Okay, so here we have a truck or a lorry on a suspension bridge. Okay, in the center of the bridge, the weight is going to be equally supported by both of the pylons. Okay, so the lorry's weight is 24,000 newtons, so it means that each of the pylons, column A and column B, are going to support 12,000 newtons each. Easy because it's 50-50. However, when the truck moves, or the lorry moves, you'll see that this becomes disproportionate, that exchange of force. So when the lorry is above column A, all of the weight force is going to be applied on column A. So lorry weight 24,000 newtons. That means that the column A is basically supporting 24,000 newtons and column B supports nothing. It has no support. And then if it moves a quarter across the bridge, and you can see the ratios here, then it's going to be basically column A bears 3/4 of the weight force, okay, 16,000 newtons, and column B is going to bear a quarter of that weight force, 8,000. Okay, 16,000 plus 8,000 equals 24,000. And then if it's 2/3 across the bridge, so 3/4 of the way across the bridge in this example, then it's going to be the opposite. Okay, so in that particular case, once it's 3/4 across the bridge, then column B bears most of the weight, 18,000 newtons, and then column A is going to bear less. It's going to be only a quarter, 6,000 newtons. Okay, so that's the important principle when you're considering if you're an engineer building bridges. And that is all we need to cover today in the concept of moments in physics.